Mars is the Earth's space cousin. It's the fourth planet in our solar system, about half the size of the Earth. It also has two small moon buddies, Phobos and Deimos. These moons are shaped like potatoes. Phobos is the drama king, moving closer to Mars and planning a crash landing in about 50 million years. Deimos is much calmer though, hanging out farther away from Mars. Mars got a cool nickname, the Red Planet, thanks to its rusty red surface. This color was so bright that it was spotted by astronomers many years ago. Even you can sometimes see it in the sky with the naked eye, a small scarlet dot. And maybe it has hot vibes, but in reality, Mars is a very cold desert. The temperatures there can drop as low as minus 240 degrees Fahrenheit. But was Mars always nothing more than a rusty-looking desert? Actually, no. Scientists believe that perhaps many years ago, this planet was similar to ours. Meet Curiosity, the detective rover made by NASA's Jet Propulsion Laboratory. Scientists want to know all about the Martian weather, landscape, and other stuff like that. Curiosity is a pretty heavy car-sized robot. It weighs about 1,985 pounds. It embarked on its journey on November 26, 2011. The rover pulled off a landing on Mars on August 6, 2012. Originally, Curiosity's mission was supposed to last for 2 years, but it's still going strong. Curiosity is basically a space lab on wheels. It's packed with cameras, spectrometers, radiation detectors, and sensors to sniff out the Martian environment. As Curiosity roams around, it rewinds Mars history. And during its mission, the rover discovered something incredible: signs of lakes and rivers from long ago. You see, Curiosity's favorite spot to play around is Gale Crater. It's a prehistoric Martian oasis where water might have hung out. There's this huge mountain in the middle called Mount Sharp. This place is taller than 10 Eiffel Towers stacked on top of each other. And it's got layers of rocks that hold Mars's ancient secrets. Recently, scientists spotted something great when studying Curiosity's data: mud tracks. What's so surprising about that? Well, these aren't just any old tracks. They're like messages from the past. They mean that the Martian ground used to get wet and then dry out again. The mud on the ground would shrink and crack during the drying phases, making these T-shaped junctions. Moreover, it seems like the ground on Mars went through several wet-dry cycles. It happened maybe up to 10 times. This made the junctions turn into Y-shaped cracks. When a bunch of Y-shaped cracks got together, they made a super cool pattern, something like a patchwork of hexagons. It looked just like honeycombs or even a dragon's skin. Each of these hexagons are the size of candy. Similar cycles have happened on Earth, and they're linked to the birth of life. When water dries up, it leaves behind concentrated stuff that's great for chemical reactions, and these reactions might be the same ones that kickstart life. These hexagons have been hanging around for a really long time, billions of years. That means that Mars once had a climate kind of like Earth's, and maybe even life. In fact, the Red Planet even has some signs of water right now, in the form of hidden ice at the poles. Mars has the North and South poles, and just like with the Earth, they're Red Planet's ice caps. Picture the North Cap as a big, icy pancake about 620 miles wide. The South Cap is a bit smaller, about 220 miles wide, but it's got a thicker ice layer, almost like a snowball with a strong shell. When it's winter at the poles, it's an incredibly long nighttime. No sunlight, just chilly darkness. During that time, around 30% of the air turns into frozen CO2. It's dry ice, the same stuff that's often used in horror movies. But when the poles wake up to sunlight, the dry ice turns back into gas. All this freezing and thawing makes clouds and frost, just like on Earth. One time, a rover named Opportunity even caught some clouds made of water ice. But it doesn't necessarily mean Mars was once thriving just like the Earth. Life needs more than just wet, dry cycles to pop up. It needs the right atmosphere and other special ingredients. We're not sure if Mars had all of those, and even if it did, there's no guarantee that life actually happened. But this raises another very important question. has Mars ever hosted tiny living creatures? Curiosity isn't the only robot that tries to find the answer to that. There's also a rover called Perseverance. It's trying to find clues about Martian life. It's digging into an old Martian crater once filled with water. And like a space archaeologist, Perseverance is searching for fossilized signs of ancient critters. And here's the funny thing. Some scientists think that we've stumbled upon it almost half a century ago. The only problem is, we might have accidentally destroyed it. It happened even before Curiosity started rolling around Mars. Back in the 1980s, two cool NASA's landers, Viking 1 and Viking 2, made a pit stop on the Red Planet. These landers took a selfie, and then they also did some funky experiments on the Martian soil, all in the name of finding signs of life. What they found is some weird organic stuff called perchlorate. It's a compound that we use in fireworks or rocket fuel. But most results didn't seem that promising. They even mixed up some soil with water and nutrients, hoping that if there were Martian microbes, they'd snack on the goodies and return radioactive gas as a result. But unfortunately, that didn't happen. Now, here's the problem. Some scientists think that maybe the water they added back then actually destroyed those tiny Martian critters. Poor microbes were just hanging out and suddenly got soaked by a bunch of weird liquid. Something like this wouldn't be very pleasant for the Earth microbes. They live inside rocks, and they're sucking water from the air. Pouring water on them would result in a total disaster. So, of course, giving them nutrients after that wouldn't do anything. If you've just barely survived a water bath, you're probably not in the mood for a feast. Perhaps these Martian buddies might have something called hydrogen peroxide in their cells. It helps them live in an extreme environment. If that's true, it could explain all the results from the experiments. You see, the instruments heated up the samples, so if there was hydrogen peroxide, it would have gone boom, wiping off the little guys and turning their cozy homes instantly. Imagine how ridiculous it would be if it turns out that we accidentally destroyed the only signs of life on Mars. Ideally, we need a new mission to Mars to test this theory. Let's hope it's not true. In any case, the journey isn't over. There are more missions planned for Mars, and humans might even visit this planet someday. The next mission is the Mars Sample Return. It's a super cool teamwork project between NASA and ESA. They're teaming up to bring back souvenirs from Mars, collected by NASA's trusty Mars Perseverance rover. There's going to be a whole bunch of spaceships. They'll work together to bring these precious Mars samples back. The samples are planned to arrive on Earth in the early to mid-2030s. And the fun doesn't stop at Mars. Our Mars missions are a warm-up for an even bigger adventure, exploring icy moons around Saturn and Jupiter. These moons have hidden oceans beneath their icy surfaces, and who knows what kinds of space secrets they're hiding. But whether it's Mars, icy moons, or beyond, our quest to find extraterrestrial life continues. In addition, we are slowly starting to find more and more organic materials on Mars. And maybe one day, we'll finally find some microbes in our solar system. Let's hope for it and stay tuned.
Imagine a still, frozen world. It's ancient, about 4.5 billion years old. It's barely heated by the rays of the sun and covered with a thick layer of ice. This world is smaller than our moon, but a bit larger than Pluto. Its name is Europa, the sixth satellite of Jupiter and one of the biggest moons in the solar system. But the coolest thing about this faraway place, it might host life. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking missions to access such a deep environment. On the bright side, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are two great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Interestingly, the new discovery about these shallow pools came about by sheer luck. The scientist leading the research, Riley Kohlberg, accidentally saw a presentation of his colleague, a planetary scientist. That scientist showed a picture of double ridges on the surface of Europa, and Kohlberg remembered that he had seen similar ridges on Earth. But while such formations are rare on our planet, they are way more numerous on Europa. The following studies suggested that the ridges on Jupiter's moon might be the result of a specific cycle, similar to that on Earth. In this cycle, liquid water freezes and then thaws inside an ice sheet, which is a rather high-pressure environment. This causes the sheet to move upward over and over again, creating a two-peaked structure. Or at least that's what happens on Earth. If the processes on Europa are similar, it can prove the presence of shallow waters on the satellite. Of course, the temperature, pressure, and chemistry are very different on Europa, and scientists don't know yet how the ice behaves there. That's why they can't understand how deep or large the water pockets are, or how long they need to refreeze. But what is more or less clear is that such under-ice environments on Europa are very likely to be protected from Jupiter's harsh radiation battering the satellite's surface, which in turn increases the chances of life existing on Europa. Now, can we get back to the fact that the ocean on Europa seems to be salty? Red streaks on the satellite's surface might have this color due to their chemical content. They're likely a frozen mixture of water and salts. This is quite unusual because such a composition doesn't match any known substance here on Earth. As for yellow spots on Europa's surface, those might be caused by the presence of sodium chloride. You know this substance as good old table salt. Scientists tried to recreate the conditions on Europa in a lab. They discovered that by combining water, table salt, freezing temperatures, and high pressure, they could get a new kind of solid crystal. This substance might exist both at the bottom of Europa's ocean and on the moon's surface. But besides this information, researchers are in the dark. Hopefully, we'll find the answers to some of these questions around 2030. That's when a mission called Europa Clipper, which is going to be launched by NASA, will probably reach Europa. The mission is going to have several close flybys and figure out if any form of life can exist on the moon. The European Space Agency's JUICE, which stands for the Jupiter Icy Moons Explorer, is going to visit Europa in the next couple of years too. But Europa isn't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example by cattle digesting food. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet, and it happened 600 times faster than researchers' models accounted for. The question, what or who generated the gas, and where did it go? Another Martian mystery is microbes that may be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Which means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the surface temperature is similar to that of dry ice. In other words, the surface of the planet is deeply frozen, and still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Now let's move to Venus. In 2020, scientists announced that in the toxic Venusian atmosphere, there was something that might mean the existence of life. Unfortunately, scientists didn't have any evidence, since there was no chance to collect any microbe specimens or snap any pictures of extraterrestrial life. But they claimed that they had discovered a chemical called phosphine there, and it was a big deal. If it wasn't some previously unknown chemistry that was producing this gas, then there could be some kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any terrestrial life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen, for example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. It can also be produced industrially. Come to think of it, phosphine isn't supposed to be in Venus's atmosphere altogether. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, famous gas giants. But on Venus, totally unexpected. There's no way phosphine can be naturally produced on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere, but not as much as astronomers thought they had observed. And it had to make scientists suspicious, but they were too happy about their discovery. They probably thought it meant there could be life on Venus. But even if this gas was created by some mysterious organisms, it would be a big question how they survived on Venus. On our planet, some microbes can thrive in environments with an acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid, containing more than 90% of sulfuric acid. The Venusian atmosphere is also 50 times as dry as the driest place on our home planet. And indeed, in 2022, thanks to better and more high-resolution telescopes, it was concluded that there was no phosphine in Venus's atmosphere. Or even if there was, it was a very small amount. So far, we need to look for signs of life further away from Earth.
And we have liftoff of the Mars Global Surveyor as America begins its journey back to the Red Planet.
There's a weird structure on Mars, a square, a near-perfect square standing alone in the endless red desert. And it looks too perfect, too precise to be anything but artificial. Nature's chaotic, and it rarely makes things look so deliberate. So the internet took one look at it and lost its mind, as the internet tends to do. The image spread like a virus on social media, igniting every conspiracy theory you can think of. Some were convinced it was proof that intelligent life had once tread upon the Martian sands. Well, let's dive in and sort it out. The image is real, and it's really old. The thing, not the picture. NASA's Mars Orbiter camera snapped it in 2001, capturing a tiny slice of Martian terrain, and there sat the square. Now, is that evidence for intelligent life? Well, Mars is an empty world now, a rust-colored desert. But once, long ago, it may have been something else entirely. A planet filled with roaring rivers, vast oceans, and thick clouds rolling across the sky. Now, in a world like that, life, if it ever had a chance, could have taken root. And there's a possibility it did. Scientists think that life could have existed on Mars in a short period from around 4.1 to 3 billion years ago. It could have started during the early era of Martian history, called the Noachian period, and lasted all the way to the late Hesperian period. Meanwhile, here on Earth, the first oceans were just forming. Life on our planet was just beginning, in the form of tiny bacteria in deep-sea hydrothermal vents. While Mars was already fully wet, on Earth, there were no plants or animals, just microscopic life trying to survive. So, Mars took the lead in the life game. It had a much thicker atmosphere, which could have trapped enough heat to keep water liquid. Valley networks, huge traces across the red landscape, show us the incredible story of rainfall, rivers, and lakes. Huge asteroids were still hitting Mars at the time, and they could have brought organic molecules with them. But if that's true, What happened, and where did life go? A recent NASA study suggests that the answer is more complicated than we thought. Astronomers believe that something drastic happened to Mars, like boom, and its cozy climate was gone, its atmosphere thinned. Without a strong magnetic field like Earth's to protect it, solar radiation stripped away the air, leaving Mars cold and dry. The ocean simply evaporated. Some of the water escaped into space while the rest froze underground or became locked in polar ice caps. Today, all that remains is a ghostly memory, dry channels and salty mineral deposits. But it looks like the transition wasn't sudden at all. It was slow and gradual. The planet was changing from wet and warm to cold and dry over millions of years. In fact, Mars kept its ocean even after the temperatures dropped to freezing. Some parts of Mars, especially the northern lowlands, might have remained wet for many, many centuries. Shouldn't the water freeze when it gets below 32 degrees Fahrenheit? Well, yeah. But there are many reasons why this miracle happened, like Mars's thick atmosphere and warm water traveling through currents. And during that time we mentioned before, from Noachian to the late Hesperian, life could have found a way. Microbes on Earth thrive in some of the harshest places, beneath Antarctic ice, in deep sea vents, in toxic volcanic lakes. Hey, life doesn't care. So these times in Martian history would be amazing for it. But don't be mistaken, Mars was never a paradise. Even during its cozy times, it wasn't as lush and green as we might imagine. In its early days, Mars was something more extreme, something closer to the young Earth. During the Noachian period, it was warm yet wet. Then, the climate shifted into the Hesperian period. Oceans were stretching across the northern lowlands. Temperatures dropped, and snow piled high, forming massive glaciers in the south, transforming the planet into an icy world. Finding microscopic life at that time is possible, but an intelligent civilization? That's less likely. The square that went viral isn't evidence for intelligent life yet, and here's why. First things first, people freak out because nature doesn't make straight lines. But that's not really true. Actually, nature does it all the time. For example, here on Earth, we have the Giant's Causeway in Northern Ireland, a beautiful field of hexagonal basalt columns. These are completely natural. They're formed by volcanic activity. There's also the Devil's Tower in Wyoming. Hey, remember it from the Close Encounters movie in the 80s? That's a symmetrical rock formation, and it was created by erosion. However, if we looked at these things from space, they'd look artificial. So, what is the square? How about a fracture pattern in the rock or some terrain that's broken apart along straight lines due to stress? This happens on Earth all the time when rock expands and contracts over time. And on Mars, the surface is just constantly battered by meteors, winds, and extreme temperature shifts. No wonder rock would get stressed. What happens here is another case of pareidolia. It's our brain's favorite thing, to spot patterns in something random. Hey, we evolved like this. So sometimes we might look at natural objects and see insane stuff. Faces on trees, animals in clouds, shapes, and so on. Besides, NASA has been photographing Mars for decades. We have high-resolution images of craters, mountains, valleys, riverbeds, hey, everything. Wouldn't an ancient civilization leave us, well, something better than some square-like rock? Even though things erode over time, we'd find more signs, roads, foundations, artifacts, ruins, or at least something. Though, to be fair, we do see something. The square wouldn't be the first time Mars has played tricks on us. Over the years, we've spotted everything, from tunnels to carved faces, even Bigfoot. Or this doorway, for example, a perfectly cut rectangular opening. That's what people saw when NASA's Curiosity rover sent back an image of the East Cliffs on Mount Sharp. It's almost like an ancient passage leading deep into the surface. You just need to go in and find some fantastic underground base. Well, NASA decided to take a closer look at it. It turns out it's just 12 inches tall and 16 inches wide, the size of a dog door. That's because what we're looking at isn't a doorway. but an open fracture, a break in the rock that happens naturally over time. These kinds of cracks are extremely common, both on Earth and on Mars. They form when bedrock is stressed, expands, contracts, or gets eroded by wind and time. If you walk through a desert here on Earth, you'd see plenty of similar shapes. Canyons, cliffs, and even boulders have fractures that, from the right angle, might look like doorways. They're just not getting photographed by NASA. Also, the straightness of lines turns out to be just a trick of perspective. If you zoom out, you'll see that it's just one small break in a much bigger rock formation. Or the infamous Cydonia face. The photo was taken back in 1976 by NASA's Viking 1 orbiter when it was scanning Mars. In the region known as Cydonia, it captured what looked like a massive humanoid face, a rocky formation about 1.2 miles long. And this one face inspired books, documentaries, movies, and podcasts. But when NASA's Viking orbiters first took pictures of Cydonia, the cameras weren't super advanced. The image of the face had a low resolution and made the details fuzzy. NASA's later missions had far better cameras, and when Mars Global Surveyor revisited Cydonia in 2001, the truth was undeniable. The face was just a hill, a lumpy rock formation with ridges and depressions carved by wind and erosion. And in 2006, during another mission, a colored image with insanely high detail was made. No traces of face left there whatsoever. That's another pareidolia trick for you. Now, Mars has plenty of secrets left to uncover, but they will be related to its fascinating history, not some secret ancient civilization. The conclusion is, don't trust everything you see online. Sometimes a mysterious rock is just a rock. Like the little engine that could, NASA's Curiosity rover has been bravely crawling over Gale Crater on Mars, trying to see what could have happened billions of years ago that made the planet a red desert. And it looks like it might have finally stumbled upon something. While life seems impossible on Mars now, eons ago, it may have been a world more like Earth, with a thick atmosphere, water, and maybe even life. And it seems things changed just recently. Studies show that just 3 billion years ago, the northern hemisphere of Mars might have hosted a stable ocean. On Earth, the Archean eon was in full swing. Volcanoes were going crazy, and life was taking its first steps. Life was also perhaps taking its first steps on Mars. No, not a frozen wasteland like Antarctica, but in a body of water like an Earth ocean. And this Earth-like climate extended Mars's habitable period by about 500 million years more than we thought before. In other words, there was a 500 million years where it was exactly like Earth, with conditions just right for life to start forming. But then, something happened that changed things forever. The atmosphere thinned, Mars lost its oceans, and became the cold, desolate place we see today. It's been a mystery for a while, but now, Curiosity stumbled upon something interesting in the Gale Crater, a vast basin on the Martian surface where billions of years ago, water once flowed freely. It found carbonates, stuff that can tell us all about the ancient Martian climate. There are minerals that form when carbon dioxide, or CO2, dissolves in water, which means that, to create them, you need two things: a nice thick atmosphere and liquid water. Now on Earth, CO2 is super important because it helps trap heat from the sun in our atmosphere. This keeps our planet warm enough to support life. Plants eat it during photosynthesis to create oxygen, which humans and animals need to breathe. On Mars, the presence of CO2 shows that there really was some kind of climate system. When CO2 starts dissolving in water, it reacts with certain minerals in the ground, like calcium or magnesium, and creates carbonates. That's kind of how seashells form in oceans here on Earth. But instead, it's happening with rocks on Mars. And this discovery is huge. These carbonates act like fossils of the planet's ancient climate. They store information about what Mars was like long ago. By studying them, scientists can get a peek into Mars' past back in the day when water was present. They can tell us how the Martian atmosphere has changed over time. show whether the atmosphere was warm or cold, or if there was a lot of water around, and what happened to the planet in general. Luckily, Curiosity can study this stuff right there. It has the sample analysis at Mars and tunable laser spectrometer. Those are like Mars's forensic tools. The SAM is a mini lab on wheels, and it's capable of heating Martian rock samples to extreme temperatures. There are 2 ovens that can heat samples to about 1,800 degrees Fahrenheit. This intense heat causes rocks to release gases trapped inside, the ones that are like ancient fingerprints of Mars, atmosphere. Once they're released, the TLS analyzes them in detail, breaking them down to the tiniest parts. And what the scientists discovered blew away all our previous assumptions about Mars' habitability. Turns out, it's not just about Mars once being wet, but there was something that led to the gradual drying and cooling of the planet. In other words, Mars's water didn't just disappear. It evaporated quickly under extreme conditions. So, what happened to it? Astronomers produced 2 possible explanations. The first one says that Mars went through periods where it was sometimes wet and sometimes dry. The water didn't last a long time. It may have appeared in short bursts, with periods where it would dry up and then return. The second possibility is more intense. The water that was there was incredibly salty and cold, so instead of being liquid, it was mostly frozen in ice. This would have made the planet way too harsh for life as we know it, since the conditions would have been too extreme for anything to survive. Both possibilities sadly mean that Mars wasn't cozy and full of life in the past like some hoped. Well, at least not on the surface. That doesn't mean underground life couldn't exist though. This one is still a possibility. And to find more, we must keep looking for hints of water now. Actually, after years of exploring Mars, scientists have just made a mind-blowing discovery. Deep beneath the rocky surface of the red planet lies a hidden reservoir of liquid water. Real water this time, not the frozen ice caps or vapor in the atmosphere, though it's miles below the Martian crust. This breakthrough comes from data collected by NASA's InSight lander. This guy spent 4 years listening to the subtle tremors of Mars. You know, Mars quakes. And it analyzed over 1,300 of them. Thanks to this, scientists were able to map out how seismic waves move through the planet. And it revealed pockets of liquid water buried 6 to 12 miles underground. Not just one lake, but puddles. So they used the same methods we here on Earth use to find underground water, oil, and gas. And they were able to piece together the Martian underground system. You see, as the water disappeared and dried out, some of it escaped into space when Mars lost its thick protective atmosphere. However, this discovery shows that much of the water didn't disappear. It just sank deep underground, where it still lies today. So close, but out of reach. That's a huge step forward. Water is the most important molecule when it comes to shaping the destiny of a planet. And also, even though we said that Mars wasn't filled with life before, this doesn't take away the possibility of it having life now. If liquid water still exists deep underground, could there be some little microbes hiding there as well? Life as we know it can't survive without liquid water. And now, with this, the idea of life on Mars has become more plausible than ever. There's a catch, though. While this water may seem like a jackpot to future Mars colonization plans, it's not going to be easy to reach. To say that drilling 6 miles deep into the crust is no small feat is an understatement. Just so you know, here on Earth, the deepest we've drilled is about 7.5 miles. It was in the Kola Super Deep Borehole project. And this project pushed current technology to its limits. Intense heat, pressure, equipment failures, you name it. With Mars, that would be even crazier. It has a much colder environment, extremely thin atmosphere, and lack of infrastructure. That would make any drilling mission extremely difficult. To reach water reservoirs buried so deep on Mars, we would need specialized drilling equipment that would somehow get delivered there. It should also be able to handle extreme cold, low pressure, and different gravity. Oh, and it should all operate remotely and preferably not break, all while it needs tons of energy. Yeah. Now, it's possible that we would only be able to do this in the future when we'll have automated systems or astronauts on Mars. That's not a quick task for even the most ambitious billionaires. So, for now, what these reservoirs hide is a mystery. But at least it's not the only one. As we mentioned, Mars hides one of the greatest secrets beneath its frozen southern pole, another buried vast lake of liquid water. The radar revealed it as it scanned the ice cap in this region. Hey, just don't make me pronounce it. Now, it's weird that it managed to stay liquid with such low temperatures. It's probably because of the geothermal heat beneath Mars' surface, and life could be there too. So now they're thinking about probing this lake first. That would be much easier. Curiosity's work is incredible, and it keeps helping us peel back the layers of Mars' ancient climate, giving us new pieces to the puzzle of what happened to our neighbor. And this could help us avoid similar mistakes in the future. We've been dreaming about life on Mars for a long time. Not only about growing potatoes there in the future, but also about all the potatoes that could have been there in the past. Has there ever been life on Mars? Recently, scientists have found something that could be evidence of that. Let's find out what happened. Mars is the fourth planet from the Sun. A human hasn't set foot on Mars yet, but robots have set their wheels. The first spacecraft that visited the Red Planet were NASA Viking landers. They flew there back in 1976 and sent us a lot of interesting data. Back then, we didn't know anything about Mars. To us, it looked like a cold, lifeless desert. But since we're so similar, scientists began to wonder, has it always been like this? Or is it possible that once Mars used to be thriving and full of life? And in 2022, NASA's Mars rover Perseverance found something that could shed a light on this mystery. But first of all, what is Perseverance? Scientists have suggested that if there was life on Mars once, it's unlikely that it could simply disappear without a trace. It must have left some traces, perhaps underground, where they would be protected from radioactive solar tantrums and other nastiness. So we need to check the rocks. It's important to note that we aren't looking for life on Mars right now. There most likely isn't any. Instead, we want to look into the distant past of our twin planet. We're talking billions of years ago, when Mars could have been warm, green, and far from lifeless. In other words, we have to find dead microbes and various chemical compounds similar to ones on the Earth. This is the mission of our main character, Perseverance. It arrived on Mars in February of 2021. The spacecraft landed on the bottom of the 30-mile-wide Jezero crater, and after landing, it scooted over to the west, to the place that prompted scientists to choose Jezero for research. This place is a dried-up river delta, and this former river is already more than 3.5 billion years old. The Jezero crater itself was once a large lake. Yup, apparently there was life on Mars, and scientists have suggested that these places would be perfect as bodyguards of microbes. That's exactly what bacteria do on Earth. They hide, being still in the depths of lakes and ponds, so we could probably find traces there. The researchers believe that this particular lake has the highest scientific value in the entire mission. The highest chance to find rocks on which such bacteria could survive is here in Jezero. So Perseverance went to the delta. The row wasn't easy though. The rover missed a little and landed further than planned. As one famous movie said, "This little maneuver's going to cost us 51 years." Fortunately, Perseverance took only 1 year, and on the way, it was able to explore Jezero a little. The rover uses a complex built-in tool to explore the world. The tool is called Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals, or just SHERLOC. Boy, NASA sure loves its acronyms. As the device approached the delta, the signal of organic molecules became stronger. Soon, these signals were everywhere, and besides, they were the brightest that the scientists have ever seen. What does it mean? Elementary, my dear Watson. You know, Sherlock. It's time to dig. Since July 2021, Perseverance has drilled and collected 4 thin cores of sedimentary rock. The total number of collected rocks at the moment is 12. This is the first time in history that we're collecting something like this on another planet. These 4 cores were found on 2 rocks called Skinner Ridge and Wildcat Ridge. The first pair of cores, the ones from the Skinner Ridge, don't seem very interesting at first glance. They're quite close to what we can find in many places on Earth. However, if we look at them closer, we'll see that they're dotted with round grains of some dark material. These dark grains could have once been deposited on them by an ancient river, the same one that flowed into Jezero. It's possible that the river brought them from places hundreds of miles away from Jezero, and that's pretty cool. If we study these cores, we'll be able to learn even more about the far corners of Mars. Well, there are no corners on it, but you get the idea. Then, in April 2022, Perseverance did arrive at the delta, and then scientists finally found what they were looking for. The discovery, to put it mildly, excited them. They found 2 more cores, which held organic substances. This pair was taken from the Wildcat Ridge. It's found very close to the Skinner Ridge, but the 2 rocks are quite different from each other. These samples are lighter in color and more uniform. Most likely, they're mudstone, an unusual rock similar to clay, but harder and unable to absorb water. They're also finer grained than the cores of the Skinner Ridge. Why does it matter? Because the finer the grains in the stone, the more likely it is that there may be some traces of a past life in it. On Earth, fine-grained stones most often lie on the bottoms of ponds and in similar places. There, they can preserve the remains of dead organisms and similar stuff for years. And this is exactly what we found on them. Additionally, according to scientists, there was more organic matter in these 2 cores than in any other place studied by Perseverance so far. It probably accumulated there while the lake was gradually evaporating billions of years ago. So, there really was life on Mars? Well, let's slow down a little. Organic substances are molecules holding carbon. And yes, on Earth, they're most often associated with life, but not always. Sometimes they can form as a result of other things. Therefore, we cannot say for sure whether there was life on Mars. We don't know if these molecules really remain from some Martian microbes, or if they're the result of some other things. But the discovery is still very significant. We have to literally keep digging this way. To learn more about this organic matter, scientists need to collect a couple more samples of fine-grained rock. It would also be great to study the material lying around these former reservoirs. Perseverance has already moved to another area, to a place with a beautiful name, Enchanted Lake. Now it needs to look for similar things there. It will also continue to study Lake Jezero. Eventually, Perseverance will climb to the top of the delta and then continue exploring ancient sites outside the crater. Sometime before the end of 2022, Perseverance will probably have 6 or more samples of the Martian cores. Unfortunately, its tools, though complex, are quite limited. This data alone won't be enough for us to get a complete picture. Therefore, NASA plans to send other spacecraft to Jezero in the coming years. Together with the European Space Agency, they're working on the next robotic mission, known as the Mars Sample Return. The name speaks for itself. These devices will arrive and take away all the test tubes from the old Prospector Perseverance. After that, these samples will be delivered to Earth, though not by Amazon Prime, and then scientists will be able to analyze them in advanced laboratories. However, all this will take a really long time. The launch of this mission is scheduled for 2027-2028, and the spacecrafts won't be able to return until 2033. But if everything goes well, it will be the first samples in history delivered to Earth from Mars. In other words, there's still enough space for research, literally. And yes, we don't yet know the true meaning of these finds. But that's why the entire mission was created, right? And who knows? Maybe in a few years we'll finally find out the truth about what happened on Mars billions of years ago. Ooh, check out the Martian! Made you look. To look.
Chances are, we're going to find life beyond Earth by 2035, and there's no need to travel to a galaxy far, far away. Our Milky Way galaxy is full of totally suitable environments. Don't get too hyped up though. We're talking about microbes or chemical markers, not Hollywood-like green humanoids. Even so, when we finally find traces of life, it will change how we see our place in the universe. NASA's Kepler Space Telescope discovered something incredible. Almost every star has planets, and many of these planets might be habitable. Rocky planets like Earth and Mars are even more common in our galaxy than gas giants like Saturn and Jupiter. Also, we already know that our galaxy is very rich in water. There's water in interstellar clouds where stars and planets form, in the debris disks around other stars, in comets, just everywhere. What's really hard though is finding life itself. Ideally, to finally find it, we need to land on every single planet out there and literally check under each rock. But thanks to the newest research, we can at least narrow down the search to potentially habitable worlds. The James Webb Space Telescope, a super powerful telescope that was launched into space in 2021, is onto this. It checks the atmospheres of nearby super-Earths, rocky planets that are a bit bigger than Earth. It searches for life-related gases, chemicals that can only be produced by living things. And they already found some clues. For example, they detected signs of such a chemical on a planet called K2-18b. This planet is 120 light-years away, which is pretty close on a space scale. This planet is in the Goldilocks zone, which means a zone around the star where the temperatures are just right for liquid water to exist. It orbits a red dwarf star, the smallest type of star there is. Such stars are a bit fainter than our Sun. It will take about a year to check if these hints of life are real. If so, it would mean that life is much more common than we previously thought. But even if it's not, there are 10 more Goldilocks planets on their list to study. The James Webb Space Telescope is a very cool tool, but it has limits. It can't detect small Earth-like planets due to their size. To fix this, NASA plans to launch another tool, the Wide Field Infrared Survey Telescope. This one will be even better at spotting such planets and life-related chemicals. And also, we have the SETI project. SETI stands for Search for Extraterrestrial Intelligence. This project has been on a hunt for extraterrestrial creatures since the 1980s. They also believe that we'll find signs of life within the next 10 years. Not so long ago, they started a super big and cool project. It's called COSMIC, and it uses an array of radio telescopes in New Mexico. You might have seen those in the movie Contact. COSMIC allows scientists to listen to hundreds of thousands and potentially millions of star systems at the same time. If there are any interesting signals, scientists can check them right away, instead of waiting for weeks or even months. The signals themselves are often very sudden and short, but COSMIC can detect even the shortest ones that last nanoseconds. COSMIC can also help with other research, like studying mysterious and unexplained fast radio bursts, or even dark matter. This is the biggest and most powerful tool for searching for extraterrestrial life we've ever created. But it's not enough to just listen. Why don't we reach out ourselves? NASA has sent some signals into deep space. In 2002, their Deep Space Network sent a signal to the Pioneer 10 satellite. But there was an obstacle in the path. A white dwarf star, 27 light-years away from Earth. If there's a planet around this star, perhaps the signal reached them too. If there are any intelligent species there, we could receive a reply by 2029. The DSN keeps sending powerful transmissions into space. These signals will bump into 222 stars within the next 3 centuries. Maybe someday we'll receive a reply from somewhere far away. But why haven't we received a response yet? There are about 200 billion galaxies in the universe, each with around 100 billion stars. If just 1% of those stars had one planet, that's still 200 quintillion possible planets. And we can narrow it down even further. If the chance of them having life is 1 in a trillion, that would still leave us a few 100,000 planets. So, where is everyone? This is a famous question known as the Fermi paradox. The first possibility isn't that terrifying. It's possible that the universe is full of life, but this life isn't intelligent in our traditional sense. Some planets might have microbes, birds, or space dinosaurs. This is called the Great Filter Theory. It suggests that there are certain filters that life has to overcome in order to become intelligent, and maybe other species just haven't overcome them yet. Think about it. Life on Earth started in the ocean, then crawled onto land, diversified into many forms, went extinct in massive events 5 times, evolved again, and eventually led to humans. We built societies, developed healthcare, and only then started searching for another life. There's another idea called the Gaian bottleneck hypothesis, which suggests basically the same thing. While it might not be too hard for basic life to start, it's incredibly tough for that life to survive and thrive over long periods. Venus might have had oceans and Earth-like conditions too, but something went wrong. Its oceans boiled away because of a runaway greenhouse effect. Now it's sterile. Mars also had liquid water on its surface once, and both the Moon and Mercury had thick atmospheres for a short time. Meanwhile, Earth has had liquid water on its surface for almost its entire existence. It's super rare and remarkable for a planet to hold temperatures from 32 to 212 degrees Fahrenheit for millions of years. So, maybe it's a mistake to look for intelligent life, especially the one that uses the same technology as we do. It evolved under completely different conditions after all. That's also where the so-called Drake equation comes in. It's a formula that gives us a chance to calculate the potential of life becoming intelligent on a planet. To calculate the result, we need to know several variables: how many stars there are, how many of them have planets, the chance of these planets having life, and so on. Unfortunately, we don't know these numbers yet, and the result might be insignificant. But let's assume that there is at least one other intelligent species. Why haven't we met yet? There might be many reasons. Maybe they don't think we're interesting enough, or maybe the problem is with us. Perhaps we keep missing their signals, or maybe we miss the entire species itself. The universe is insanely huge and ancient. It's over 14 billion years old. If we compress Earth's entire evolutionary history into a 24-hour day, life starts at 4 a.m. Dinosaurs go extinct at 11:40 p.m. Human-like creatures appear 2 minutes before midnight. In this analogy, humans have existed for just 77 seconds, and our technology capable of detecting extraterrestrial life is even newer, less than a second. With such vast distances and time spans, the chances of us existing at the same time as other civilizations are slim. If their civilization lasted only a few millennia, we could easily miss them entirely. But that doesn't mean we should give up our search. Scientists were worried that Earth's radio signals had dimmed over time. But a recent study showed that it's actually the opposite. The numbers of our satellites keeps growing, and this makes our planet more detectable. By the end of the decade, we could have 100,000 satellites, making Earth incredibly bright in the radio spectrum. If there is an advanced civilization out there, they will easily spot us even from very far distances. Astronomers are super optimistic about it. There's a high chance they'll find extraterrestrial creatures while you and I are still around.